So for this project, we decided to do a very fun clamp, as you can see here. So this project was done by Justin Jackson, Dustin Tran, Zach Cassidy, and David Beasley. Our project description, we designed and fabricated a functional model of an Irwin quick grip locking clamp using 3D printing technology. And over on the right, you can see the model that we used in order to model it. The design process consisted of 5 distinct phases: a purchase of 2 quick grip locking clamps. Then we determined measurements from the purchase models, created CAD drawings, and converted those into G-code files in order for the 3D printing to read the files, the 3D printing of each individual piece, and then finally assembling the final product. We decided to purchase 2 locking clamps for $25, which was about $6.25 per person from a local hardware store. And one model was taken apart to determine the functional mechanics of the clamp. The other one was used as a final comparison to the prototype. When we measured the model, we used calipers that were provided by the College of Engineering. Precise measurements of each dimension for each piece of the model were taken and recorded. And some dimensions were unfortunately not easily measured because they were so small. Also, some of the angles were very difficult to measure, and these had to be speculated.
This is on the right, a picture of me doing the 3D modeling of the design. We used the measurements that we took from the purchase model and made a 3D CAD drawing and tried to make it as close as possible to the purchase model. Some issues that we ran into were, as said before, there were some measurements that we couldn't quite get because they were so small and we couldn't get them accurately. And so there had to be some adjustments to be made and some speculation. And once the CAD drawings were completed, they were converted into individual STP files as stated before so that they could be read by the 3D printers. Here's some pictures of the final CAD drawings. On the left, you can see that it was fully assembled. We also had rotating joints on each part that was supposed to move so that we could see how exactly it would move once it was 3D printed. You can see on the right, each part taken apart. This was actually taken before we adjusted which type of screw that we use. One problem that we had with 3D printing using files from Inventor was that the threading in Inventor for 3D modeling is actually just an image and it does not actually thread the object. So we tried to print out a screw that was threaded and make a threaded hole, but the image did not actually print through the 3D printer. These are some more of the drawings with some dimensions on what we did. As you can see through there, these are all in millimeters and they're still quite small numbers. The clamp had very tight tolerances and we noticed this immediately, and that's why we chose 3D printing in the first place. And you can see on the right that the total amount of dimensions is quite a few, and it was really hard to find exactly where to place everything, especially when doing the 3D drawings. So on the right, you can see there's a video playing of us 3D printing out our object. And according to the book, 3D printing is a process in which the printer builds up parts gradually by the addition of material under full digital control. In our project, we 3D printed each part individually to make the clamp based on CAD drawings that we did previously. Due to the nature of the clamp, the tight tolerances allowable through 3D printing caused us to choose this process. And those tight tolerances, as you will see later, also led to some complications.
So the assembly didn't go as exactly as we planned. We thought we could just print out the pieces and they would fit together perfectly. But due to the small tolerances, that wasn't the case. So we had to do some filing and some drilling on some parts in order to make it fit and function how we wanted it to. And this is our final outcome. It ended up working very well. And here it is next to the model that we ended up basing it off of. And on the next slide, we have a video that'll show its function. So here's a video of it actually working. did a pretty good job of clamping. The main thing was really just the material wasn't quite as good as the original model that we bought. And for lessons learned, one of the main lessons that we learned was that the scaling needed to be done when switching the CAD file to G-code. So as you can see in the picture on the right, we've got 2 clamps, and the one on the right was actually our first print before we scaled it. And we also learned that the print doesn't always come out as smooth as we want. And we had to kind of sand it out ourselves, again, due to the small tolerances. And then finally, our clamp functioned well, but like I mentioned before, the material was cheap and brittle. So it wasn't always feasible, or it wouldn't be feasible to manufacture it this way in the future.